Hello and welcome to this session. In this session, we will take a detailed look at the single responsibility principle and the thought process that brought this principle into being. Take a look at this class. The name of the class is Square. It has four methods: calculate area, calculate perimeter, draw, and rotate. The calculate area and calculate perimeter functions do exactly what they're supposed to do. They calculate the area and perimeter of a square given the length of its side. The draw function renders the image of the square on the display. It has multiple code flows depending on what type of display is being used. The rotate function rotates the image of the square and re-renders it on the display. In the context of this code snippet, we will learn about a new concept termed cohesion. Cohesion in the software world is defined as the degree to which the various parts of a software component are related. If you think that's a mouthful, let's take a quick detour and look at this visual. Here you see garbage that looks unsegregated. You cannot really come up with a relation between all of the contents of this garbage can. It has a wide variety of items like plastic cans, beer bottles, paper waste, etc. But let's look at how it looks after it gets segregated. Very nice. Take a look at the yellow bin for plastics. There are a number of plastic bottles inside the bin. The bottles are not alike. But if you look at all the contents of the yellow bin, they have a common relation. They are all made up of plastic. If we apply the definition of cohesion here, which says that cohesion is the degree of relation, we could say that the contents of the unsegregated waste bin have a low cohesion, and the contents of each of the segregated waste bins have a high cohesion. Enough of garbage, huh? Let's get back to our code snippet. Let's apply the same principle here. What do you make of the methods inside the Square class? The methods calculate area and calculate perimeter are closely related in that they deal with the measurements of a square. So there is a high level of cohesion between these two methods. The draw method and the rotate method deal with rendering the image of the square in a certain way on the display. So there is a high level of cohesion between these two methods as well. But if you take all of the methods as a whole, the level of cohesion is low. For instance, the calculate perimeter method is not closely related to the draw method, as they deal with entirely different responsibilities. So I am going to do some shuffling so as to increase the level of cohesion. Let me take these draw and rotate methods and move them to a different class. I'll name the class as Square UI. By doing this, even though I have split the methods into two classes, I have increased the level of cohesion in each of the classes. All the two methods inside the Square class are now closely related as both of them deal with the measurements of the square. All the two methods inside the Square UI class are now closely related as both of them deal with the graphic rendering of the square. So one aspect of the single responsibility principle is that we should always aim for high cohesion within a component. Component means class in this case. If there is high cohesion between all methods of a class, we can assign a single responsibility to all the methods as a whole. For example, for the first class square, we can safely say that the responsibility of the square class as a whole is to deal with the measurements related to a square. Similarly, for the second class square UI, we can safely say that the responsibility of the square UI class as a whole is to deal with rendering the image of a square. So we just saw how aiming for higher cohesion can help us move towards conforming to the single responsibility principle. Like cohesion, there is another concept that we need to look at. It's termed coupling. Coupling is defined as the level of interdependency between various software components. Again, let's take the help of a visual here. Take a look at these two trains. What do you notice about the width of the tracks? This is standard gauge rail. This is broad gauge rail. Standard gauge is 1.4 meters wide. Broad gauge is 1.6 meters wide. The difference in width makes it two entirely different railway systems. For example, the width of the train for standard gauge is different from that of broad gauge. One train cannot move on a track of a different gauge. So this train cannot go on this track and this train cannot go on this track. In other words, a train is tightly coupled to its track. Tight coupling may be a necessity in railways, but in software, tight coupling is an undesirable feature. We'll see why. Let's go back now and revisit our definition. So coupling is defined as the level of interdependency between various software components. Let's see a code snippet now. Here's a class, student. One of the methods inside the student class is the save method. The save method will convert the student class into a serialized form and persist it into a database. You can see that this method deals with a lot of low-level details related to handling record insertion into a database. Let's assume the database you are using now is MySQL. Sometime in the future, if you decide to go with a NoSQL database like, say, MongoDB, most of this code will need to change. So you can see that the student class is tightly coupled with the database layer we use at the backend, just like the train is tightly coupled to the track. The student class should ideally deal with only basic student-related functionalities like getting student ID, date of birth, address, etc. The student class should not be made cognizant of the low-level details related to dealing with the backend database. So tight coupling is bad in software. So how do we fix this? We'll take the database-related code and we'll move it into a new repository class. Then we'll refer to this repository method from inside the student class. By doing so, we have removed the tight coupling and made it loose. So now if we change the underlying database, the student class does not need to get changed and recompiled. You only need to change the repository class. If you look at this in terms of responsibilities, the student class has the responsibility of dealing with core student-related data, and the repository class has a single responsibility of dealing with database operations. So by removing tight coupling and making the coupling loose, we are again abiding by the single responsibility principle. So to sum up, we looked at two concepts, cohesion and coupling. We also saw how low cohesion is bad. Single responsibility principle always advocates higher cohesion. We also saw how tight coupling is bad. Single responsibility principle always recommends loose coupling. So, always aim for higher cohesion and loose coupling. That's it for this session. I hope the two concepts are clear. Let's now move ahead to the next session.